Hey, I'm Jason with Edge Energy to explain the blower door test. What we have set up here behind us is the Infiltech DM4 manometer and E3 blower door. It's made by a Virginia-based company down in Roanoke. What we have here is the actual fan unit itself, assembled in with the blower door frame. I've got my manometer, which is a device to measure pressure differences, attached already with different hoses, and then also our fan speed control module here below to control the fan speed. So what we're running is a pressure test to measure the outside pressure versus the inside pressure at varying fan speeds. Even more simply, what we're doing is we're blowing a lot of air out the front door of the house, several thousand cubic feet of air per minute. For the house to compensate that pressure imbalance, it needs to bring in that much air from somewhere else in the building shell. What we're going to get out of that information is the cumulative amount of building shell leakage at natural pressures when the house is under normal conditions and we're not elevating the pressure difference with the blower fan. So why don't we get started here and we'll do some data real quick. So the fan spins up slowly. 50 pascals, we're at 1611. 45, we are at 1445. And at 40, we're at 1288. So we just took 3 quick measurements with the blower door. Typically in an energy audit, we'll take 10 different pressure readings and then calculate back through logarithmic regression what the exact amount of building shell leakage is. And from that data, we can use a couple of other formulas to extrapolate out moisture control loads, how much air your house needs for minimum ventilation or suggested indoor air quality from ASHRAE, and uncover a couple of other issues possibly with the HVAC equipment that you're going to want to know about as far as depressurization or combustion safety issues. So this is our IR camera booting up. What this is going to show us is the surface temperature of an object, and based off of what we see in the infrared photo, we can use some of our building expertise to identify whether that's an air leakage site or whether it's possibly low levels of insulation. And this thing will actually see whether there's even mold or mildew or some water damage behind the walls. This is a very important part to any energy audit, mainly because it will show you something that's invisible to the naked eye, and then you can go ahead and base some of your conclusions and your retrofit ideas off of what we find in the infrared.
What we're looking at is pretty much the leakiest object in the house, which is usually the attic hatch, pull down staircase, or any other access to the attic is usually the leakiest. There's simple fixes for this, just simple weather stripping and insulating the hatch will do the trick here. But one of the patterns we're looking for are any kind of streakage patterns. So if you see one area and then you see some air movement and you see little streakage patterns on that we know that there's air movement coming in and around from that area. If we're looking on here and we see any spots that are completely warm, just solid warm spots, that's usually missing or low levels of insulation for us, and what we'll do is identify those and we'll get up in the attic space afterwards to visibly see that. But normally we're looking for any cold or, in this case, warm areas. Just single spots are basically low levels of insulation, and streakage patterns are areas where there's air movement actually coming in through that. So we're looking at both convective and conductive losses.